Hi, in this video lecture, we discuss design and analysis of algorithm, first unit, summary concepts. So this is the last video of design and analysis of algorithm, unit 1 topics. So I have hosted 6 videos related to design and analysis of algorithms in the YouTube. So this video will help you a lot to summarize the concepts which were covered in Unit 1 of Design and Analysis of Algorithm course. Let us start the session. Now here I am sharing the screen of summary sheet. In the first unit, the listed topics were covered. Those topics are, you may expect the questions in the university level which are covered in first unit of design and analysis of algorithms. The questions are, the first one is, what is algorithm? What is algorithm? Algorithm definition, they may ask for 2 marks question in universities. So basically, why algorithm is required in the sense is algorithm is required for everyone in their human life because algorithm will tell you how to write a program. Algorithm will tell you how to solve a problem, step-by-step procedure. An algorithm is a step-by-step procedure to solve computational problems. To solve computational problems. Or another definition of an algorithm is an algorithm is a finite, not infinite, remember here, finite sequence of steps or instructions to solve a problem that is known as an algorithm. So you can answer the question with any one of the answer listed here. You may get full marks. So finally, we can conclude that algorithm is used by anyone to solve any type of problem in their life. So if you know the step-by-step procedure of an algorithm, step-by-step procedure to solve the problem, so that is considered as an algorithm. But the question is, in which language we need to develop an algorithm in the sense, there is no specific language for writing an algorithm. Always we will write the algorithm by using English language only, by using any natural language only. Next question is, why algorithms are really required? Why algorithms are really required? So basically, algorithms are required to solve the problems. But algorithms are required for software industry because the software industry implementation and design of a programming are going up nowadays. If you see any software industry, the programs are designed, they are implementing the programs, they are testing the programs. But if you want to write a program, if you want to design a program, if you want to run a program, the software developers or the software engineers will know the step-by-step procedure how to solve the problem. That will exactly give you by the source is algorithm here. So the answer is why algorithms are really required is to design better programs, algorithms are required. For writing normal programs, okay. For design better programs, algorithms is help a lot. So this is the answer. The next question is, so we already discussed algorithms is used in our day-to-day life. Some of the examples of algorithms are noted here. Preparation of a tea. If you want to prepare a tea, there is a step-by-step procedure for preparing a tea. If you want to construct a building, the building may not be constructed in a day. A proper planning is required, proper analysis is required, proper design is required, and a proper implementation is required for constructing a building. So that step-by-step procedure can be provided by an algorithm. Next one is Google Maps. So one of the familiar map is Google Maps nowadays. If you want to travel from city to another city, there are many possible ways. Among those possible ways, you need to select the best possible way, which is shortest path. So that step-by-step procedure will be given by an algorithm. You can learn those concepts through the algorithm only. Another one is YouTube recommendation systems. Whenever you are working with YouTube recommendation system, if you want to search an online shopping sites, so whatever the item or product you want to search, the product related same type of products will be reflected over the screen. The system will recommend you to purchase this also. So this type of coding is to be developed, coding is to be running at the background. So algorithm real-time examples are these are notable algorithm real-time examples. Next question is, what is the difference between algorithm and program? So basically, which one is comes first? Algorithm will comes first or program comes first? The question is here. So algorithm comes first. Later on, based on the algorithm only, the program is to be developed and the program is to be implemented. Algorithm is designed based on the design of an algorithm. A program is to be developed and a program is to be implemented and a program is to be tested. But in algorithm, what we are doing, we are simply doing only design. That means that algorithm will comes first, later on program will comes first. If you consider a simple example, software development life cycle, SDLC. Whenever we are working with any software development life cycle project, there are some phases like analysis phase, design phase, implementation phase, coding phase, implementation phase, and testing phase. So these are a sequence of steps. The sequence of steps is required for completing a project through software development life cycle. In this case, the programmer, the software developers, or the software testers are mainly involved in that for developing the program. Software developers will develop the program, whereas a software tester may test the developed program without any errors to find the bugs. But here the question is, while developing or implementing the program by a software developer or software tester, they do not have any domain knowledge. They have only programming language, but they don't know or they are lacking of domain knowledge. But they need one algorithm to develop any program. The software developers need the help of an algorithm. What algorithm will do? Algorithm will comes in the design phase in SDLC. Algorithm comes in the design phase of SDLC, whereas program comes in the implementation phase or development phase in the SDLC. So the main difference between algorithm and programming is algorithm is developed in the design phase in SDLC. Program is implemented and tested in the design development phase only. The second difference is algorithm while preparing an algorithm, while writing an algorithm that can be done by if that can be written in a natural language or that can be written in a English language. Whereas programs can be written in programmatical language. If you want to develop the program using C, you need to write the program in C language or C++ language, Java language, Python language, or some other languages, etc. So algorithm, while writing an algorithm, we need to write an algorithm using any natural language or English. Programs can be written in any one of the program languages which are available in the market. Next major difference between algorithm and programming is in algorithms, the person is having domain knowledge. Who are writing an algorithm, the person is having domain knowledge. But in programs, the person should not have any domain knowledge. Algorithms should not based, should not depend on any operating system or any hardware component in the computer. Whereas programs will always depend on hardware component of the systems as well as the operating system which was installed in the computer. So these are well noted and defined differences between algorithms and programs. If you have a good algorithm in your hand, it will boost up for writing a better programming. So this is the final answer. Next question is, what are the properties of an algorithm? Or they may ask the question like that only. What are the characteristics of an algorithm? Both are same. Properties of an algorithm and characteristics of an algorithm. Both questions are same. The answer is the algorithm characteristics depends on 5 categories which are listed over here. The first one is input, second one is output, unambiguous, finiteness, and last is effectiveness. These are well noted algorithm properties as well as algorithm characteristics. So the first one is input. Basically, whenever you are writing an algorithm, how many inputs are required? The algorithm will require 0 or more inputs. The algorithm requires 0 or more inputs. The algorithm produce one or more outputs. The algorithm produce one or more outcomes. Next, unambiguous. Whenever you are writing an algorithm, you should not be, you should be clear from your side. While preparing an algorithm, the design of the design person should have clear picture, should have domain knowledge. There is no ambiguity while writing an algorithm. Next one is finiteness. So whenever we are writing an algorithm, step-by-step procedure to solve the program, the algorithm steps can be terminated in some set of instructions. That means that the algorithm instructions should be finite, not infinite. And last one is effectiveness. So algorithms will be very effective when you can write the better performed algorithms with the help of the factors. So these are various characteristics or properties of an algorithm. Next question is, what are the advantages and disadvantages of an algorithm? So the advantages of algorithm is, through algorithms, communication among the programs will be very effective and easy debugging. We can able to debug the program very easily through the algorithm. Debugging in the sense, debugging is the process in which finding the errors and identifying the errors and provide the solution for those errors is known as debugging. Easy and efficient coding. So based on the step-by-step procedure of an algorithm, the software programmer will have a provision for preparing or developing better and very efficient coding programming language, independent programming language. So these are various advantages of an algorithm. But what are the disadvantages of an algorithm? Algorithm disadvantage is, algorithm can be suitable for solving small programs only. If you want to solve, if you want to develop an algorithm for complex problems, it is time consuming process and it is very difficult to understand also. So that's why algorithms are recommended for solving small programs only, not for complex problems. Developing an algorithm for complex problem is a time consuming and difficult task. Next question is algorithm specifications. Here there is a question, how to write an algorithm and what are the procedures we are following and writing an algorithm. While preparing an algorithm, you require domain knowledge only. Domain knowledge only. And next one is, algorithm can be prepared in any one of the natural language like English. So we already studied this too. But there are three ways we can prepare an algorithm. We can solve or we can describe an algorithm in three ways. The first one is natural language. So in English, we can draft an algorithm, step-by-step procedure to solve the problem. We need to write or prepare an algorithm in a natural language. This is the first concept. And sometimes you may write an algorithm through flowcharts, that is called graphical representation part. You can show the algorithm through the graphical representation part with the help of flowcharts. So this is also another algorithm specifications. But flowcharts can be supported for smaller, to solve small programs only. Whereas natural language also support for small programs only. If you want to write an algorithm, if you want to develop an algorithm for complex problems, to solve complex problems, in this case, you can better select pseudocode for an algorithm while writing an algorithm. Pseudocode is not a programming language. Pseudocode, it is not a programming language. Just it is a language. Pseudocode is a language that can be written by a software designer, software architect, or develop the pseudocode. So once the pseudocode is prepared, based on the pseudocode only, the program will be developed and the program will be tested. So there are some rules and guidelines which are framed while preparing the pseudocode. These good guidelines will help you a lot for writing better algorithms. And here the difference among flowchart, pseudocode, and algorithm. This is another question. Algorithm is used to solve a problem, whereas flowchart is used to represent an algorithm, but it is a graphical way. Pseudocode is a not programming language. It is just a language for representing an algorithm. But here, knowledge is required while preparing an algorithm. Knowledge is not required while preparing flowchart. And knowledge is not required while preparing or writing pseudocode. So this is the difference among these three. Next question is, what is recursive function? Very important question, this one. Recursive in the sense called by itself. Call by itself. A function can call by itself is known as recursive function. What is recursive algorithm? An algorithm can call by itself is known as recursive algorithm. Basically, these recursive algorithms can be seen in some of the programs like factorial of a given number and Fibonacci of a given number. These are the best examples for recursive algorithm. Now let us see how recursive algorithm work in a factorial of a given number. If you see the factorial of 5, what is factorial of 5? 5 into 5 minus 1 factorial. 5 into 5 minus 1 in the sense 4 factorial. And again, you need to solve 4 factorial. 5 into 4 into 3 factorial. Again, you need to solve factorial of 3. That means that, so what is the procedure you are following to solve factorial of 5? That can be implemented for next step also, factorial 4. That can be implemented for next step also, factorial 3. This will continue till the program ends. It is called as a recursive algorithm. Another one is Fibonacci series. In the Fibonacci series, the first two numbers are constant, 1 and 1. Add these two numbers, we will get the answer. 1 plus 1, 2. We will get the answer is 2. Now add this 2 with the previous value. 2 plus 1, 3. Now add 3 with the previous value. 3 plus 2, 5. So what is the methodology here we are adopting? The same methodology can be implemented for the upcoming result values also. So a function can call by itself. It is known as recursive algorithm. Next question is very important topic. What is mean by performance of an algorithm? The writing of an algorithm is a task. Once the writing of an algorithm is over, you need to focus on measure the performance of an algorithm. How we can say the performance of an algorithm is good or the performance of an algorithm is bad? That means that how fastly the algorithm works will mainly depends on performance of an analysis. The performance of an algorithm can be analyzed based on some principles. There are 6 principles which are listed over here. Among them, only 2 are very important. The first one is time complexity, and the second one is space complexity. Time complexity and space complexity are 2 important principles or factors which can be used to measure the performance of an algorithm. So while measuring the performance of an algorithm, let us discuss what is time complexity. Time complexity in the sense, the amount of time required for executing and compiling a task is known as time complexity of an algorithm. Here, the time complexity of a particular algorithm can be depends on in any one of the category while measuring. There are best case time complexity, worst case time complexity, and average case time complexity. Best case time complexity in the sense amount of time required or takes an algorithm to execute the program in a minimum number of steps. That means that if you want to solve a algorithm will took less number of steps to complete the solve the problem. Less number of steps. That is called best case. If any algorithm takes maximum possible number of steps to complete the task, that is called worst case time complexity. If an algorithm takes average number of steps to complete the task, given task, it is considered as a average case complexity. Let us take a simple example. Simple example. The example is sorting. Sorting. If you want to sort the elements in an array, there are 10 elements in an array. If you are to sort the elements in an array, you can sort the elements. You need a step-by-step procedure. If the given answer is, whenever you want to test the array elements are sorted or not, the elements are already sorted, but to execute the task or to compile the task, how much time is required? Only one step is required. That is called best case. It will take maximum number of steps. If it is reversed to that one, the elements are not sorted, the elements are in the randomized order. In this case, if you want to sort the elements, it will take maximum number of steps. Maximum number of steps. So that is called worst case. If you want to spend minimum number of steps, that is best. Maximum number of steps, that is worst. Average number of steps, that is average case time complexity. Another example, let us discuss binary search. In binary search, some elements are listed in the array. Find a particular element. Want to find a particular element. Whatever the element we are searching in the array, the element is first element. That will comes under best case time complexity. Why? Because within a single step you can able to search the element. If the element is last element, you want to search the last element. You need to search the elements. You need to search the searchable element with the element. It will take maximum number of times. That is called as a worst case, average case time complexity. If the element is not found, whatever the searchable element, the element is not found in the given array list, there is never ending process. You may not find the answer. In this case, it is considered as a worst case time complexity. So these are the examples for measuring the time complexity of an algorithm. So how to calculate time complexity? Next question is how to calculate time complexity. There is a formula. While calculating the time complexity, you can use this formula. Time complexity is equal to the sum of algorithm compile time and algorithm runtime. An algorithm compile time plus algorithm runtime. Finally, we will get the time complexity of the given algorithm. For that, we can written a formula is T of n, time required for an algorithm equal to C. C is a constant that is considered as a compile time, and R suffix P is a runtime. So compile time of an algorithm plus runtime of an algorithm, finally we will get the time complexity of the given algorithm. While calculating the time complexity of an algorithm, you need to find how many number of times each and every instruction of an algorithm can be executed. The count is important. You need to calculate the count for each and every instruction. So finally, you need to add the total number of instructions and ignore the constant values. You will get the answer. Next question is, what are asymptotic notations? Why these notations are required? Asymptotic notations are required basically. We cannot say, we cannot say the performance of an algorithm exactly this one. It is upper bound, lower bound, or middle bound. That can be treated, that can be done through the asymptotic notations only. There are three asymptotic notations are required to represent the growth of an algorithm as the input value increases. Some of the well familiar asymptotic notations are big O notation. So this is the symbol for representing big O and which can be used to measure the upper bound of an algorithm. The second one is big omega notation. We can consider as a omega notation. This is used for measuring the lower bound. And theta notation. This is used for considering the average bound. So the definitions of asymptotic notations and the definition of big O notation, omega notation, theta notations comparison will be discussed in this slide. Consider the function f of n is the function and g of f is another function. When we can consider that a function is said to be big O of g of n if and only if there exist all positive constants listed over here C and n naught such that always the given function f of n is less than or equal to constant value into g of n for all n greater than n naught. So this is the definition of a big O notation, and here a function is said to be omega notation if and only if there exist all positive constants C and n naught such that f of n is simply reverse here. F of n is greater than or equal to constant into g of n for all n greater than or equal to n naught. So the first one is definition is for big O notation. The second definition is for omega notation, and at last this is for theta notation. Theta notation definition is a function is said to be theta notation of g of n if and only if there exist all positive constants. Here the constants are not limited to one. There are two different constants, namely constant 1 and constant 2, and the function lies between these two constants. The given function f of n lies between c1 and c2. So here the given function is greater than or equal to, here the given function is less than or equal to. When the given function is less than or equal to, it is upper bound. When the given function is greater than or equal to, it is lower bound. When the given function is in between the constant values C1, C2, it is a average case notation. In this way, we can represent the asymptotic notations. Next topic is amortized complexity. What is mean by amortized complexity? This is very important question. Amortized complexity in the sense, basically, whenever we are calculating time complexity of an algorithm, total steps, each and every step will be executed some number of times. We need to add all the steps and we will neglect the constant values, we will get the algorithm. We will get the time complexity of the given algorithm. This is the procedure we are following. But here, in worst case time complexity, we cannot say this is exactly worst case. In this case also, to provide the better time complexity than worst case time complexity, this amortized complexity will help you a lot. How it is, in amortized time complexity, we need to calculate the time complexity for each and every line of code, each and every instruction of a code in an algorithm. That will gives you better time complexity whenever you are performing calculating the time complexity of an algorithm. There are three main techniques which can be used for measuring or calculating the amortized analysis of an algorithm. The first one is aggregate method. This aggregate method is applicable for some of the well-noted examples are array list whereas hash table. So array list and hash tables are data structures which can be used to perform algorithm related tasks. If you consider a hash table or array list, the elements are listed or placed over here. If the array size is full, whenever you want to do some operations like insert a new element or searching the existing element in the array list, there is no space to place the new element in the array. Why? Because the array is full. The array is full, no space. In this case, you need to increase the size of an array. The increased size of an array, it will become double the size of an array. So that can be happen through this amortized time complexity only. Next one is Next method is accounting method or banker's method. This method is used in banking systems to avoid deadlock systems. To avoid deadlock systems. That means whenever a person applied for a loan, whether he is eligible for loan or his application will be accepted or not accepted, rejected, that will be mainly depends on this algorithm only. Next one is the potential methods. That is, split trees here we are using for potential methods or physics methods. So these are various amortized complexity techniques. Next one is typical complexities of an algorithm. What are various typical complexities of an algorithm and what is the order of growth of an algorithm? This is the question for online questions. So you may expect one question from this typical time complexity or typical complexity of an algorithm. So complexity of an algorithm in the sense, so while after calculating the time complexity of an algorithm, the algorithm time complexity can measure order of n, big O of n, big O of log n, big O of n square, big O of n cube. These are considered as the complexity of an algorithm. The complexity of an algorithm can be in any one of the form, like the first one is constant. Constant in the sense, so order of one is the constant. Logarithmic means order of n. Order of n is logarithmic. Linear, log n is linear. Quadratic, cubic, order of n cube is a cubic. Quadratic in the sense order of n square is quadratic. Exponential is order of 2 power n. So these are various typical complexities of an algorithm. So some of the typical complexities of an algorithm which are listed in the table, seems to be the order of growth rate of an algorithm. The order of growth rate of an algorithm will be clearly mentioned here. The first one is order of one. Order of one in the sense it is a constant. Next one is order of log n. This is logarithmic. Order of n, order of n into log n, order of n square, quadratic, order of n cube, cubic, order of 2 power n, exponential. In this way we can measure. So here the n value may be doubled. That means the array size is doubled. Even the array size is double, the constant values, the time complexity is one only. This will comes constant. The time complexity may vary. It will comes logarithmic. The time complexity may be doubled here. That is called linear. Like that. So we can place the algorithm where we need to place. Hi students. So I hope you all are well understood the concepts what I taught in this video lecture. Hope these topics will be helpful a lot. Thank you. Have a nice day.